Welcome to part 43 of our series on building a Zelda-like game in Phaser 3. In this video, we'll expand the boss enemy by implementing custom behavior states. We'll add logic for the hidden state, create a teleport state to reposition the boss, and start building out the prepare attack and idle states. You'll also see how the boss decides on an attack direction and preps its next move. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description and start from the beginning. Alright, let's dive in and give our boss some serious behavior. Now that we have our boss character, we can work on building out our states for our boss fight. Currently we set up our boss with our idle, our hurt, and our death states, and now we'll need to add in the rest. So we'll focus on our hide and our teleport states first. So when our player enters into our boss room, we'll update our state machine for our boss to start off in our hide state. Once we transition to this state, we're going to wait a small period of time before we transition to our teleport state. In our teleport state, our boss is going to start teleporting around to 3 different locations, and he's going to do this for a set period of time before we transition to our pre-attack state. To start creating our states, let's jump back over to our code. Let's go into our components, our state machine, our states folder. I'm going to make a new subfolder under character. We're going to call this boss. We'll make another subfolder. We'll do dro. And now add a new file. We'll do boss, dro, our hidden state. So now let's open up one of our other state files. I'm going to grab the bounce move state. I'm going to copy the code from there. We'll paste it over to our boss, dro, hidden state. I'm going to remove our code from our onEnter method. I'm going to remove our imports. Let's update our class name. So we're going to call this our boss dro hidden state. Let's fix our imports. So I'm going to do add all missing imports. Now for our state name, we'll call this hidden state. Let's copy that string. Let's jump over to our character states. We'll add that in. While we're here, we'll add in our other states we'll need. And so let's do teleport state. And we'll do prepare attack state. Alright, let's jump back over to our boss dro hidden state class. Alright, so when we trigger onEnter method, first we'll want to hide our boss character. So we're going to do this, we'll do our game object. Let's do disable game object. Now we'll want to wait a brief period of time before we re-enable our boss character and then transition to our teleport state. So let's reference our game object. We're going to do our scene. We'll do time. Let's do our delayed call. So now we just need to do our duration. For this, we'll add to our config file, and we'll call this our enemy boss hidden state duration. Now in our callback, we'll want to re-enable our object. So I'm going to copy this code. We'll paste it. Let's do enable object. And now we'll want to transition to our next state. So we'll do this, our state machine. Let's do set state. And we want to do our character states. And we want to do our teleport state. So now let's jump over to our config file. Let's copy our new config. Come to our enemy boss, we'll paste that in. For our hidden state duration, let's do 1000 milliseconds. While we're here, let's add a few more properties for our boss we'll need for other states. So I'm going to copy and paste that in. We're going to need a duration for our idle state before we transition back to our teleport state. So we'll do our enemy boss, idle state duration. For this one, we're going to do our 3000 milliseconds. Let's paste our line of code 2 more times. We'll need 2 more configuration options we'll use in our teleport state. So we'll update our variable name, and so we'll do our teleport state. And this will be our initial delay. I'm going to copy this, we'll paste it, and now we want our finish delay. So we'll do 150 milliseconds for our initial, and we'll do 500 for our finished. And so we'll cover these once we get to our teleport state, so let's jump back over to our class. Let's update our imports, and then let's save. Next, let's create our teleport state. So under our boss dro folder, let's make a new file. We're going to call this our boss dro teleport state. I'm going to copy the code from our hidden state. Let's paste that in. So now for our class name, we're going to do our boss dro, and then we'll do teleport state. We'll update our state name, and so we'll do our teleport state. So now when our boss enters our teleport state, we're going to have a list of locations where our boss can teleport to. We'll then have our boss start teleporting between those various locations for a set period of time before we transition to our next state. To keep track of those locations, let's add a property to our class. We're going to call this our possible teleport locations. For our type, this will be our phaser, our math, our vector2, and we'll do an array. So now down our constructor, we're going to do this, our possible teleport locations. We're going to pass this in as an argument, so let's copy this, we'll paste it. Let's add our argument. Now this will be the same type, so I'm just going to copy this from here. So now when we enter our onEnter method, first we're going to make our boss enemy invulnerable so they can't take damage while they're in this state. So let's do this, our game object. We're going to grab our invulnerable component, and we'll set invulnerable to be true. And now to start having our boss teleport between those various locations, we're going to use a timer event. So let's do const, we'll do time event. We're going to set it equal to this, our game object, our scene, our game object is in. We'll reference our time plugin. And now let's do add event. So now for our time event, first let's add in our delay. So this will be the number of milliseconds we wait before we start triggering this event. And so this will be our configuration we added for our teleport state. So let's do our enemy boss. We'll do our teleport state initial delay. Let's add in our callback. For the time being, we won't add anything. We'll add in the rest of our properties first. So let's do our callback scope. Let's do this. And now we'll do repeat. And now we want to repeat this event based on the number of possible teleport locations that we have. And so we'll do this. We'll do our possible teleport locations. We'll grab our length of our array. We're going to multiply it by 3 so we can repeat that. And then we'll need to subtract 1 since our repeat will be in addition to the initial call when our timer event fires. So now in our callback event, we'll want to check to see if we're finished with our timer event. And if we are, then we'll want to transition to our next state. To end that check, we'll do if our time event will get our overall progress. And so if our overall progress is equal to 1, then we know we're finished with our event. And for that, we'll call a new method on our state. And so we'll do this, and we'll do handle teleport finished. Let's add that method. So we'll have our private method. We won't have this return anything. For now, we won't do anything. And then we'll return early from our callback. If our timer event is not finished, now we want to update our game object's position to be based on one of our possible teleport locations. So for that, we're going to make a new variable, do const, we'll do location. We're going to set that equal to this, our possible teleport locations. So now to choose a location, we're going to base that on the number of times that our callback has been invoked. To keep track of that, we can use our time event, and we can grab our repeat count value. So now for our repeat count, because we're doing our length and we're multiplying it by 3, that means we'll be out of the index for our array. So we'll want to divide this by 3 and get the remainder to know our index. So we'll take our percent, and now we'll do this, our possible teleport locations, and we'll grab our length. So now that we have our location, we can do this, our game object, we'll do set position, and now we'll reference our location.x and our location.y, and not save. So real quick, for our location, what we're doing here is we're taking our repeat count, and this is going to be based on the number of times our time event has repeated. And so on the first time we call our callback, our repeat count will be set to 0. Our next time will be 1, 2, 3, and 4 until we're finally finished. So what we're doing is we're taking the length of our possible teleport locations array. And for example, if we have 3 locations, on the first time our callback's invoked, we would have a repeat count of 0. We'll divide it by 3, so we have a remainder of 0. We'll use our first index. Then we'd have 1. We'd have a remainder of 1, so we'll grab that first index. Then 2, we grab the second index, and then once we hit 3, we'll have a remainder of 0, so we'll loop back to the beginning of our array, and we'll be back at index 0. And so by doing this, it makes sure that our index stays within the actual bounds of our array. So now down in our handle teleport finish method, once our boss is finished teleporting around our room, we'll want to hide our boss game object and wait a brief period of time, and then we'll want to choose a random location and have our boss appear in that spot. Then we'll transition to our prepare attack state. So let's do this. We'll do our game object. Let's do visible. We'll set this to be false. Now we want to do our delayed call. So we'll do our game object. Let's do our scene. We'll do our time. Let's do delayed call. For our delay, we're going to do our enemy boss teleport state finish delay. So now in our callback, first we need to choose where we want our boss to teleport to. Let's make a new variable, do const. We're going to do random location. We're going to set this equal to our phaser, our utils, our array. We'll do get random. And now we're going to use our possible teleport locations array to get one of our values back. And now we can update our game object's position. And so we'll do set position. We'll do our random location X, our random location Y. And now we can make our boss visible. And so we'll do this, our game object visible will be true. And now we want to make our boss vulnerable again. And so we're going to copy this line of code here. We'll set this to be false. And now we just need to update our state. And so we'll do this, our state machine. Let's do set state. And we'll do our character states. And let's do our prepare attack state. So now that we finished our teleport state, let's add in our prepare attack state. So in our code, let's do our boss draw prepare attack state. I'm going to copy the code from our hidden state. Let's paste that in. Now for our class name, we'll do our boss draw prepare attack state. We'll update our state name, and so we'll do prepare attack state. Now let's remove our code from our onEnter method. So now before we add in our code for our prepare attack state, we're going to work on testing our existing classes to make sure everything's working as we expect. So to test our logic, let's come back to our boss class. Let's go to our state machine. We'll want to add in our new states. So let's copy the code here for our idle state. We'll paste it 3 times. First, let's do our hidden state. So we'll do our boss, our draw, our hidden state. Now we'll do our prepare attack state. So we'll have our boss, our draw, our prepare attack state. And now our teleport state. So we'll have our boss, draw, and then our teleport state. So now for our locations, we're going to have our boss teleport between the center of our screen up here and then our 2 bottom corners down here. To add those locations, let's do new, a phaser, our math, let's do vector 2. So let's do this, our scene. Let's grab our scale manager, we'll grab our width, we'll divide it by 2, and we'll do 80 for our Y. I'm going to copy that line of code, paste it twice. And now for our other locations, let's do 64 for our X, we'll do 180 for our Y. And now for our other location, and now for our other corner, we'll do 192 for our X, and we'll do 180 for our Y. Finally, to test our logic, we need to update our boss to be in our hidden state. For this, we're going to use our enable object method, and we're going to extend this so that way when our player enters into our room, when we call our enable object method to show our boss, we'll set our state at that time. Let's come down to the bottom of our class, let's add in public, we'll do enable object. First, we'll call our enable object on our parent class. So let's do super enable object. And now we'll need to set our state. So I'm going to copy our line of code here. Let's paste it. And now we want to go into our hidden state. Now let's save. And now when our browser refreshes, our boss is invisible. And then we transition to our teleport state. Oh, so it looks like we have an issue. So in our teleport state, we're referencing phaser. So let's add in that import. We'll do import star as phaser from phaser. So now we save, our boss will be hidden, he'll start teleporting around our room until finally we choose one of our possible locations and we go to our prepare attack state. So now if we refresh, our boss should randomly choose one of those 3 locations. Nice. So now in our prepare attack state, the purpose of this state is to allow us to do any setup we need before we have our boss actually attack our player. So after our boss finishes teleporting around our room, we want our boss to attack our enemy with a new weapon type, and this is going to be a dagger. For our dagger, our boss is going to throw it at our player. For this to work properly, we'll want to have our boss face our player game object and then line up our boss to be on the same horizontal or vertical line as our player. And so now to figure out which direction our boss actually needs to face, so we're facing our player, we're going to use our boss's position and compare that to our player's position. Now to do this, we're going to draw a vector between our boss game object and our player game object, and then based on that angle or the degrees of that vector, we'll know which direction our boss needs to face. So as an example, how this will work is from our boss game object, we're going to have that be position 0, 0, and we're going to draw a arrow or a vector from our boss to our player game object. Now, depending on the angle of this vector, we'll know which direction our boss needs to face. So as an example, let's say our player is to the right and down a little bit of our boss. So when our player's in this position here, we'll want our boss to face to the right, so then we're looking at our player. If our player's position was over here, we actually want our boss to face down when we go to throw our dagger. Likewise, if our player was up over here in this area, we'd want our boss to face up when we go to attack, and then if over here, we'd want our boss to face to our left. And so based on that, we can use our boss's position and compare it to our players to create that arrow or our vector to know which quadrant or angle we need to look at. And so to do that, we can draw this arrow between our boss and our player game object, or our vector. And so once we have our vector, we can now calculate our angle of that vector to know which quadrant our player is actually in. So as an example, in our current vector right here, our angle is going to be less than 45 degrees, since that's what this line is here. Now, if we moved our player over here, our vector would be updated, and now it's going to be greater than 45, but less than 90. So now, no matter where our player is at in our dungeon, we can calculate that vector between our boss and our player to get that angle. So what we can do with that information is if the angle of our vector is greater than or equal to 45 and less than 135, we know our boss needs to face down. If it's greater than or equal to 135 and less than 225, we face to the left. Greater than or equal to 225, less than 315, we need to face up. And then for any other value, we'd want to face to the right. So now to start adding in our logic, first we need to get a reference to our player game object. To do this, let's jump over to our game scene. We're going to add a new getter that's going to allow us to get our player game object. So after our constructor, let's do get, we'll do our player. For our type, let's do our player, and we're going to return this, and then our player instance. So now back in our prepare attack state, first let's get a reference to our player. So let's do const, we're going to do target enemy. We're going to set that equal to this, our game object. We want to grab our scene, and now I want to do as our game scene. Now we're going to do player. So now that we have a reference to our player game object, we can now create our vector. So let's do const, we'll do vec is going to be equal to a new phaser, our math, our vector2. And now we want to take our target enemy, we want to grab our x value, we're going to subtract our game object's current x value, and then we'll do our target enemy, we'll do our y value, and we're going to subtract our game object's y position. So now that we have our vector2, we can grab our angle from our vector. And so when we grab our angle from our vector, this is actually going to be in radians. And so if we want to use our degrees, we'll need to convert our radians to our degrees, or we need to update our logic here to use radians. For the time being, we're just going to use degrees. And so let's do const, we'll do radians. We'll set this equal to our vector, our angle. Now to get our degrees, we're going to set that equal to phaser, our math, our radians to degrees, and now we can pass in our radians. And now that we know our total number of degrees, we can update our game object's position. So we'll do if our degrees is greater than or equal to 45, and our degrees is less than 135, then we need to face down. So we'll do this, our game object. We'll do our direction. We'll set equal to direction.down. Let's copy this block of code. Now we'll do else if, and so now we'll do if it's greater than or equal to 135 and less than 225, then we need to face to the left. Else if, now if it's greater than or equal to 225 and less than 315, now we want to face up. Finally, we'll just face to the right. Alright, since we're referencing our phaser utility functions, we'll want to add our phaser import. I'm going to copy that from our teleport state. We'll add this at the top of our attack state. And now after we set our direction, we can now transition to our attack state. So let's do this. We'll do our state machine. Let's do set state. We'll do our character states, and let's do attack. Finally, to test our changes, we just need to add our attack state to our boss class. Let's go into our drill class. Let's go to where we add our states. Let's copy one of our lines of code. We'll paste it in. And now we want to add in attack state. Alright, so now if we save, back over in our browser, our boss should teleport around our room, and now it should face our player, depending on our player's position and where our boss lands. Oh, so it looks like we have an issue. Yes, we'll need to update our boss's flip X property, since when we have our boss face to the left or right, we're reusing the same sprite. So if we come back to our prepare attack state, let's reference our game object, we'll do set flip X, let's do false. Now let's copy that line of code, and when we go to have our boss face to the left, we're going to set flip X to be true. So now if we save, let's have our player move around our room a little bit. Now when our boss appears and we face to our left, we're facing in the right direction. So now if we try to move our player over to the right, our boss should face to the right. And let's see if we can get our boss to face up. Nice. Now that we have our boss facing our player, we just need to add in our logic to update our boss's position so it'll be directly across from our player. How this will work is if our boss is facing up or down, we're going to update our X value. That way it'll be vertically across from our player. If our boss is facing left or right, we're going to update our Y value so it'll be horizontally across from our player. So add those changes after we update our direction. Let's do if our game object, if our direction is equal to our direction down, or our direction up. Then we'll update our X values. We'll do this, our game object, we'll do set X, and we're going to set it equal to our target enemy or our player, our X position. Otherwise, we want to do our Y position. Let's copy this line of code. We'll paste it. And we'll do set Y, and we'll do our target enemy, our Y position. So now if we save, our boss should now appear, and now it should be vertically or horizontally across from our player. Nice. Now that we have our logic in place for our prepare attack state, we need to fix an issue with our boss where after we transition to our attack state, our boss doesn't do anything. So what's currently happening is we're transitioning to our attack state and our boss doesn't have a weapon, so we're transitioning right back to our idle state. Now our idle state is set up, so we're expecting some type of input, before we transition that character to the next state. For our boss, we're not going to have any type of input like we do with our spider. Instead, we'll want to wait a small period of time before we transition from our idle state into our teleport state. Since this logic is going to be custom to our boss, we're going to create a new custom idle state for our boss enemy, and we'll use that instead of our common idle state we have right now. So to add in this new state, let's go into our boss, our draw folder. Let's do boss draw idle state. I'm going to go into our hidden state. Let's copy our code from here. Let's paste that into our new idle state. Let's update our class name. So we'll do our boss draw idle state. Now for our state name, we'll want to do our idle state. So now when we transition into our state, we'll want to play our idle animation, wait a brief period of time, and then transition into our teleport state. So to add in that logic, I'm going to go into our idle state. I'm going to copy our logic before we play our animation. Let's remove our disable object line, and we'll paste this here. So now we're going to play our idle animation. And now for our delay call, for our delay, we'll want to reference our enemy boss, idle state duration. Alright, so now after our small delay, now we'll want to transition to our teleport state. One last thing we'll do is in our delayed call, we're going to add a safeguard to make sure we're in our idle state before we transition to our teleport state. Since this is a delayed call, there's a possibility we might not be in this state anymore when we go to run this code. So as an example, if we transition to our idle state and then our player attacks our boss, we're now going to transition to our hurt state. For our hurt state, we'll be doing our animation and then transitioning back to our teleport state. And so we don't need to run this code here. We'd actually want this to be based off our hurt state. Likewise, if our boss now dies when we take that hit, we wouldn't want to go to our teleport state. We'd want to do our death animation and have our boss disappear. So by adding in that safeguard, it'll make sure we don't transition to our teleport state if we're not supposed to. So let's do if this. We're going to reference our state machine. We're going to grab our current state name. So if our current state name is equal to our character states, our idle state, that means we're still in our idle state. And now we can do our logic for transitioning to our teleport state. So now we have our new custom idle state for our boss. Let's go to our boss class and we're going to update our state machine to use that state. So instead of doing our idle state, we're going to do our boss draw idle state. And one last thing we'll do is let's remove our logic where we set our state to our idle state by default. And we'll wait until our object gets enabled before we set our first state. Alright, so if we save, we should be able to test our changes. After our boss attacks, we should go to our new idle state, wait a brief period of time, and then we'll repeat our pattern to have our boss keep attacking our player. Nice. Next, let's try attacking our enemy. So after we attack our boss enemy, they'll transition to our idle state and then go right into our teleport state. However, after our boss teleports, now we have a very small window to attack our boss. What's happening is by default, after our boss takes damage, in our hurt state, we transition back to our idle state right away. This is causing us to register our callback twice for where we transition to our teleport state. To fix this, we'll want to update our hurt state, so instead of going to our idle state, we'll want to go right into our teleport state. So we'll pass an undefined for our unhurt callback. Now let's do our character states, and now let's do our teleport state. Let's save. Let's try attacking our boss again. So after our boss takes damage, we should teleport around, try to attack us, and then go right to idle so we have a chance to attack them. Much better. One other bug we'll want to fix is after our boss changes our direction, he'll keep facing that direction as he teleports around. So we're going to update our boss's direction to go back to our default state and then have it face our player. So let's go into our teleport state. So right before we calculate our location, we're going to update our boss's animation. So let's do this. We're going to do our game object. Let's do our direction. We'll have our boss face down while he's teleporting. Now we'll do our animations. We'll do our game object. Let's grab our animation component. Let's do play animation. Now we want to do our idle animation, followed by our suffix for our direction. And so we'll do this, our game object, our direction. Alright, so now if we save our changes, we should be able to test. Let's move our player around. After our boss teleports, they should face our player. Once he goes back into our teleport state, it'll be facing down. And if we move our player around our room, our boss should continue to update and face our player. Nice. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.